If regression analysis has ever confused you, especially interpreting data output, then this video is exactly what you need. In the next few minutes, I will walk you through this full econometrics problem step by step in the simplest way possible. By the end of this video, you will understand ANOVA, coefficients, R squared, and how to build and use regression equation with full confidence. Welcome to BioSTEM Academy. In this video, we are solving a regression analysis problem for agri-economics and extension students. We'll go through the following: one, identifying the model, interpreting the results, and making predictions, and lots more. So let's get started. This is a given problem. Given the following STATA computer printout of regression analysis of rice milling operation. This is source, sum of squares, degree of freedom, mean sum of squares, F value, and the values for probability, R squared, adjusted R squared, etc. Now, model here is the regression and with a sum of square of 3489.8 followed by residual, that is error 1285.1. Now the total, if you add this together, if you sum them, model plus residual, that is regression sum of square plus sum of square error. In our previous video, we've explained that total sum of square is equal to regression sum of square plus sum of square error. Now, if you sum this, you get 4774.9. Degree of freedom 3 plus 11, 14. And how did we get this? 1163.3 is by dividing 3489.8 by 3. You get this. Divide 1285.1 by 11, you get this, right? And now, what type of model was used in the analysis? This is the first question. What type of model was used in the analysis? So, a type of model used in the analysis. Type of model used in the analysis. So the type of model used in this analysis is nothing but multiple linear regression model. Multiple linear regression model, usually shortened as MLRM, multiple linear regression model. And why it is multiple linear regression model? Because we have one dependent variable which is gross earning, and many independent variables such as production cost, promotion cost, and season, which is a dummy variable. So the reason why it is called multiple linear regression model is because the model encompasses one dependent variable and many independent variables, one regression and many regressors, one predictor and many predictors, one endogenous variable and many exogenous variable. Is that understood? Good. So whether you see one dependent variable and multiple predictors, it is just a multiple linear regression model. Now we are done with question A. Question B, interpret the result of the regression analysis. Interpret the result of the regression analysis. Now, how do you interpret? Interpretation. interpretation of results. First of all, using the ANOVA, this is our F statistic or F value. Our F is 9.96. So the value of F is F 9.96. P value is what? 0.002. So given the P value as 0.002, and this 0.002 is what? Is less than 0.05. So since the P value for F statistic is 0.002, which is less than 0.05, we can now conclude that, the model is statistically significant, right? The model is statistically significant. Why? Because we have looked at the p-value for the F, and then it is less than 0.05. 0.002 is less than 0.05. So we conclude that the model is statistically significant. What is the importance? What does F stands for? F determines whether the entire model is significant. F statistic determines whether the entire model is significant. Is the model significant? That is, the function of what? F statistic. And if you could remember, F can also be ascertained using this formula, MSS. And as we were saying earlier, the model is statistically significant because the p-value is 0.002 and is less than 0.05. Now, F statistic, this 9.96 can be gotten using this formula, MSS regression all over MSS error or residual. So MSS regression from this table is 116.3, 116.3.3, 1163.3 divided by MSS what? Residual or MSS error, 116.8, 116.8. So if you divide this, definitely you're going to get something like this, 9.96, 9.96, right? So that is it. That's the final answer. Now the C or still in in the interpretation, we have what is called R squared. Still in our interpretation, R squared. R squared is coefficient of determination. Coefficient of determination. And what does this does? It determines the amount of changes caused by the independent variable on a dependent variable. Determines the amount of changes caused by the independent variable on the dependent variable. And this, from our table, we have 0.731. 0.731. R squared value is 0.731. Now, if you want to explain it, you multiply this by 100. 0.731 times 100 is equal to 73.1%. Right? 73.1%. Now, this means that 73.1% of the variation in our dependent variable, which is gross earning, is explained by the independent variables: promotion cost, production cost, and what? Season, which is a dummy variable. In simple terms, the model explains most of what is happening, which indicates a good fit. 73% is something acceptable. If it is 30%, the model has less effects or less contribution of the independent variables. 40% also less contribution. 50% moderate contribution of the dependent variable on the independent variable on the dependent variable. But 60%, 70%, 80%, this is what? Indicating good fits. meaning 73.1% of the variation in gross earning is explained or can be attributed by the independent variables, and the independent variables are three since it is a multiple linear regression model. These are promotion cost, production cost, and season, x1, x2, x3 respectively. We are done with R. Now coefficients are the beta values. Now beta for constant, beta for everything. Coefficient, this for production cost for x1 is 3.99. Coefficient for x1 3.99. 3.99. What does this mean? It means, and let's check the p-value, 0.003. This is also less than 0.05, so this is significant, right? Coefficient is significant. Since the p-value is less than 0.05, it is significant. So production cost is significant. And for every 3.99 means for every 1 unit increase in production cost, gross earning increases by 3.99 units. For every 1 unit increase in production cost, gross earning increases by 3.99 what? Units. Is that understood? Okay. Next is promotion cost, x2. The p-value is 0.061. Is this less than or greater than 0.05? Of course, this is greater than 0.05 because the value is 0.061. 0.061 is greater than 0.05. So this is insignificant, not significant, statistically insignificant. Okay, this we now Floxinausten nihilipificated. We regard this as what? Futile, insignificant, not important. It is not having much effect on gross earning. So that is why. Why? Because the p-value tells 0.061 is greater than 0.05. So it is insignificant. And here it means, okay, let's just move to the next variable, which is season. It's a dummy variable. 3.345. The p-value is 0.177. Of course, this is also greater than 0.05. This is insignificant. Next is constant A, right, or intercept. This is the predicted value. This constant 3.792 is the predicted value of gross earning when all the independent variable, season, promotion cost, production costs are kept constant. You don't understood? If this and this are 0, then this is the value of our gross earning. Baseline. When you have no production cost, you have no promotion cost, you have no season, your predicted value of y, that is the dependent variable, is 3.792. Is that understood? Good. Now the next is question C. Write down the estimation equation of the regression equation. Write down the estimation equation of the regression equation. C, estimation equation of the regression equation for this is y is equal to a plus b1 x1 plus b2 x2, right, plus b3 x3 plus e. But since it is an estimation equation, equation has no error. Remember in our previous video, estimation equation has no what? Error. Therefore, y cap is equal to a. The constant is 3.792. Then write down your 3.792 plus b1. b1 is 3.99. Then x1 plus b2 1.678 x2 plus b3 3.3 3.345 x3, right? So this is our estimation equation. Estimation what? Equation. Now the last one. The last question is, if the production cost and promotion cost is 2.5 and 0.75 respectively, calculate the estimated gross earning. Now, if production cost x1 is 2.5 and promotion cost x2 is what? 0.75. Calculate the estimated gross earning. So now we are taking into account only two independent variables, production cost and promotion cost. Now I use it to calculate your predicted gross earning. Then y cap is equal to a plus, right, b1 x1 plus b2 x2. So our a is 3.792 plus b1 is 3.99 times x1 2.5, given 2.5, plus b2 1.678 times x2 0.75. Now some of you might confuse and ask, why didn't we include x3? The reason why we didn't include x3 is because right from the question, only two independent variables are given. If you are given the x3 again, that decision, then you include it. But in this case, only x1 and x2. So that is why we are limiting ourselves. We are circumscribing ourselves to this two independent variables. So 3.792 plus 3.99 times 2.5. If you use your calculator, definitely, if you multiply 3.99 times 2.5, the answer is 9.975, right? Plus, next is 1.678 times 0.75. This times this is 1.2585. And if you sum this and this, you are getting 15.03, right? 15.03. So this is approximately 15. So this is our estimated gross earnings. And that is how you solve and interpret a problem, interpretation of problems in regression analysis, step by step. If this video helps you, especially in understanding econometrics, make sure you like the video and subscribe to BioStem Academy. Drop your questions in the comments and I will solve them in the next upcoming video. See you next time. Thank you.